Emirates Green Building Council Technical Workshop by Innovo. Subject: The Future of Building Design Workflows. Presented by Andres Gigan, Senior Design Manager at Innovo.
Innovo is an industry leader in construction and innovation across the built environment, specializing in the design, engineering, construction, development, and infrastructure financing of major real estate projects across 4 continents. I am an architect with 25 plus years of international experience in design and construction of a variety of projects, with a vast experience in design, coordination, and execution of projects in Argentina, Ireland, and the UAE. Today we will talk about the following: design co-creation tools, automation design versus manual design, real-time environmental model simulation, and sustainable designing, design co-creation tools. I believe that the democratization of highly specialized software in the design process makes advanced tools accessible without the need for expert training. Let that sink for a second, and then I will ask you, what are the 2 major contributors to this? Perhaps you have guessed right: artificial intelligence and cloud computing. So what is cloud computing? In simple terms, imagine instead of buying a powerful computer to store all your files and run heavy softwares, you rent space and power from a company that owns massive computers somewhere else. Cloud computing providers have huge data centers with thousands of high-speed computers that can work together from multiple locations to generate as much computing power as needed, which allows specialized software companies to provide powerful services over the cloud. So, what are the benefits of the democratization of highly specialized software then? One is the access to advanced tools without expert training. Non-specialists, like junior designers, students, or small businesses, can use complex software that previously required expert knowledge. Another one is speed up workflows. Tasks like simulation, 3D modeling, or data analysis become quicker and user-friendly thanks to simplified interfaces or AI-powered features. Also, reduce costs. Cloud-based subscription models often replace expensive software licenses, making professional-grade tools more affordable, as well as promote innovation and creativity. Greater accessibility sparks innovation by empowering creative experimentation and collaboration across disciplines. And finally, level the playing field. Smaller firms and individuals can compete with larger companies by employing the same tools without needing extensive infrastructure. Over the past 12 months, we have tested several cloud-based design tools that enable us to develop workflows capable of producing proposals in days rather than weeks. A few examples of the AI tools that we've tested are Hector, a cloud-based generative design software developed by Parametric, primarily aimed at urban planning, pre-design, and schematic design. TestFit, a real estate feasibility platform designed to streamline the site planning and deal evaluation process. Spatio, an AI tool tailored for architects, engineers, and property developers. It simplifies the building design process by combining intuitive tools for instant 3D modeling and real-time analysis, including site data integration, structured BIM-ready models, and real-time metrics for areas, efficiency, and sustainability. Schema, an AI-powered platform designed to optimize the building information modeling process. It accelerates workflows by transforming schematic designs into detailed BIM models within minutes, leveraging artificial intelligence and previous design data. Finch, an AI copilot that helps optimize building designs. It enhances the early design process by enabling rapid iterations, offering performance metrics such as space efficiency and sustainability, and ensuring compliance with rules and regulations. PromeAI, a versatile AI-powered design platform tailored to creatives across various industries, including urban planners, architects, and interior designers. It leverages artificial intelligence to transform sketches and design concepts into highly detailed and realistic renderings. We will now talk about automation versus manual design. For this, we will use one of the co-design tools previously mentioned, Spatio, to select a site here in the UAE, specifically on the Dubai Design District, to see how the software is able to generate instant 3D models on the specific site. It should be noted that many of the co-design software mentioned are mainly tailored for Europe or the United States. Nevertheless, once the site in question is selected, Spatio is able to generate options for residential buildings right out of the gate. Many parameters like building width, height, number of floor can be adjusted as desired and automatically reflected on the model. Many iterations can be generated by adjusting specific variables like building density, site use, openness, which will be automatically reflected on the model. Also, different story heights can be created depending on the uses. Alternatives facades options can be applied to the different floors as suited and automatically be reflected on the model. But as I mentioned, the automatic design generations tools for this softwares is tailored for mid-rise residential building in Europe, perhaps not the base case for a site in Dubai. So what happens if we use the software as a real co-creation tool? The modeling tools of Spatio, or any other software for that matter, can be also used to manually generate the design, perhaps with some inevitable preconception ideas from the human designer. In this case, we created the overall site volume and proceeded to carve it, slicing the site with directional tension guidelines that helps us to create different volumes, by pulling and pushing different cake pieces, so to speak, to try to create a desirable massing. This process can be as quick or as long as needed, depending of the result that are automatically reflected on the model. We then proceeded to carve an internal courtyard that will be the main feature of the design, articulating the different volumes and giving a sense of scale. As you can see, the process is very interactive and give the chance to the designer to use simple tools to generate quick design ideas that are visually appealing and highly appreciated. This is just a quick example of how cloud-based design co-creation tools can be used to generate high-level volumetric master planning and architectural ideas that are modeled to scale within a given context and easily adjusted, all without the need of use complex softwares and with tangible results within minutes. So what would happen if we tested a combined approach, partially automated and partially manual, within a compact, more sustainable design context? In this case, a smaller site in the Dubai Creek area. We select a plot within the given zone and allow the co-creation tool to algorithmically generate design options based on the required parameters. Once the desired massing is achieved, we can then switch to a more manual process to tailor the buildings according to what the designer believes is more suitable. Let's agree that this can sometimes be a subjective approach, but that's exactly what the human touch brings, a unique design. Now, to utilize co-creation tools in a correct, effective, and advantageous manner, we can make use of the power of cloud-based software to run environmental simulations that allow us to make informed design decisions from the very beginning. Simulations like daylight potential, prominent views, sun hours, and solar radiation, which provide valuable real-time information that can inform design decisions to create a better and more environmentally sustainable design. For instance, the solar radiation to the facades can help us to modify the volumes and select different material that will be tailored for the required exposure, minimizing full south-facing facades and make proper allowance for the eastern and western elevations, while at the same time make sure that the predominant views are maintained. Sustainable designing. You might wonder, what do I mean when I say sustainable designing? I believe that, for the time being at least, we have the opportunity to decide in which tasks do we want the AI-driven softwares to help us during the design process. Tasks like parking calculation can be fully automated by these co-creation tools and adjusted in real time during the early design stages. Similarly, all areas calculations like gross floor area, net internal areas, and others can be accessed at every stage of the design and automatically updated while making any design modification. Moreover, the generative design AI-driven software can automatically calculate number of vertical cores, propose units mix and others on the basis of the different clients' and authorities' requirements. There is still a lot of room for improvement in these co-creation tools. But if you consider that, like with any other AI platform that we interact today, they are going to rapidly improve and be an integral part of our design process. A typical workflow using a combination of co-creation tools is as follows. Once a site has been selected and a number of volumetric scenarios have been explored to quickly identify the potential of the site, we would then be in position to interact with other AI tools to run internal configuration algorithms to find the best suitable layout for the given volumes. At the same time, we would also export a number of views and run them through AI tools to generate related mood images tailored to the specific volumes. This workflow could be run multiple times until a desirable solution has been reached within hours instead of days. As an example, we have deployed AI copilots as a validation tool project to analyze the master plan and obtain additional data that was necessary to understand the full potential of the project. Some of the additional data gathered were the gross internal area, the percentage between the net internal and the gross floor area, the residential unit mix, etc. Moreover, we used AI tools to test the built-up area of the basements and the potential parking allocation within the basement, considering the position of the ramps and location of vertical cores. Further volumetric studies can be carried to understand the relationship between the building and to extract views to transform them into highly detailed and realistic renderings to illustrate the early facade design intent that would help to visualize the potential of the development. This is all nice and well, but I am here at the Green Building Council giving a talk about AI and cloud computing. And some of you might be wondering, what are the CO2 emissions that are being generated by all of these? AI and cloud computing are estimated to account for approximately 2.5% to 3.7% of global greenhouse gas emissions. In comparison, the aviation industry is responsible for approximately 2.4% of global emissions. But if we put this into a broader context, the livestock sector accounts for approximately 14.5% of global greenhouse gas emissions. And this is a conservative estimate, not including the emissions generated by agricultural practices involved in cultivating and transporting the crops used to feed livestock, among other factors. So how much CO2 does ChatGPT generate? You might have seen in the news recently in social media that apparently saying please and thank you to ChatGPT cost millions of dollars. Basically, OpenAI CEO Sam Altman responded to a user on X who was curious on how much money OpenAI has lost in electricity costs for people showing good manners to their AI models. Well, a single ChatGPT query uses 2.9 watt-hour, which it is 10 times more than a single Google search. The monthly carbon footprint has been estimated to be equivalent to that of 260 transatlantic flights. Definitely, new technologies put more pressure on the use of natural resources and CO2 emissions, and we all should be mindful of this. So, the question that I will put forward to you is, shall we be polite to a robot or not? In order to save OpenAI some dollars by reducing electricity consumption. My view on this is that OpenAI managed to create ChatGPT into a revolutionary technology. They should be able to work around this and code into the software to disregard this word or some other solution. I personally want my kids to be polite when they ask for something, whether they're speaking to a real person or a robot, at least until they're old enough to decide for themselves whether they want to be rude out in the world or not. This is all from me. I appreciate your time and I hope you found this interesting and insightful. Thank you.